All right. So let's go ahead and talk a little bit about probability more. Okay. We said if we have an event E, the complement of the event, complement of E is, we notated by E prime. And we said the complement of E will be anything, everything in the sample that is not in E. Yeah? So for instance, if we say, let E be rolling a number less than 3 on a 6-sided die. So if we say let E be rolling a number, less than 3 on a 6-sided die, then E prime will be the number greater or equal to 3. If we're looking at the event E being a number less than 3 on a 6-sided die, then E prime would be the opposite. What's the opposite of less than 3? It has to be bigger or equal to 3. Yes? So, for instance, find the probability of E and probability of E prime. So we want to find the probability of either one of them, or both of them. Yes? To find the probability, we said, if we want to look at the probability of E, that would be N of E divided by N of the sample space. And if we want to find the probability of E prime, that would be N of E prime divided by N of the sample space. So for each case, we need to determine what kind of outcomes I'm expecting from that event. So first, let's write down the sample space. So the sample space that I have rolling a die, or a 6-sided die, will consist of 6 outcomes. And those outcomes are 1, 2, 3, 4, 5, and 6. So far, so good? All right. So now, let's talk about event E. What are the outcomes from the sample that are less than 3? Is 3 included? No, because we're talking about less than 3. Yeah? So what are the outcomes that are not less than 3? Is 3 or 5, 6. Yeah? So N of the sample space equals 6, correct? N of E equal 2, and then N of E prime equal 4. Yeah? Now notice, if I add E and E prime, I'll get the sample space. Yes? because E prime is everything else other than E. Yeah. So now when we go to the probability, so probability of E equal 2 over 6, which is 1/3. Yeah. Probability of E prime equal 4 over 6, which is 2/3. This is using the formulas that we have. But we did find, notice what happened if I said if I add all of the outcomes from E and E prime, I get the whole sample space. Yeah? So we could also say probability of E plus probability of E prime, because both of these represent all the sample space, then that has to equal to 1, because that's the most the probability can be, correct? So probability of E prime equal 1 minus probability of E, if I move this to the other side. And if I use this, 1 minus 1/3 is also what? 2/3. So I could have just satisfied myself by figuring out what E is, yeah? And then once I find the probability of E, I can subtract it from 1 to get the probability of the complement. Sometimes this method or this way is a whole lot easier than finding exactly what we're looking for. Sometimes finding what we're looking for may need to do a whole lot of calculation, yes? But if we end up finding the opposite and subtracting it from 1, would be a whole lot easier. Yes? For instance, let's take before I get into this one, let's figure out again outcomes. Suppose you are at the ice cream place, yeah, and you want to buy ice cream. Let's say they have 3 different sizes, yes, 3 different sizes, and let's say they have 10 different flavors. 10 different flavors. We're going to make that easy, yeah? How many possible choices do you have? How many? 30, yes? From the first size, let's say from the large, you can choose any of the 10 different flavors, correct? So you can choose 10 with a large, 10 with a medium, 10 with a small. So that means you have how many? 30 different flavors, yeah? Well, that's one way of doing it. Or you can multiply. 3 times 10 is 30. When we're looking at scenarios or instances in which they happen or they occur one after the other, then we can multiply their possible outcomes to determine how many outcomes we could have in the sample space. Yeah? Suppose, for instance, you have 3 different shoes. Yeah? You have 4 different pants. Okay? And say 6 different shirts. And they all mix together nicely. How many different outcomes can you have? How many different dresswear can you have? Well, if I were to multiply all of these, if I were to multiply over these, I'm going to end up with 72 different ways to dress. 72 different ways to dress. Because if I take a pants and the shoes, we just follow the same procedure, right? Pants and a shirt, we follow this procedure. With every pants, I can have 6 different shirts, right? So that is 24 different ways. And then we have 3 and 24 different outcomes. With every outcome, I can wear different shoes, right? So with the shoe number 1, I can have a 24 dress way. With shoe number 2, I can have 24, and then 24, that would be 72. And people say they don't have enough clothes. That's that's horrible. So you can have 72 days. You can go out 72 days a year with those combinations. Never wear the same thing twice. It's the same outfit twice. Okay? So if I was looking at the number of ways I can put things together, that will give me how many. By multiply them, because the instances are happening one after the other. Yes? So now, with that explained, let's talk a little bit about what we were supposed to talk about. Suppose you roll 2 dice. So roll in 2 dice. Yes? Roll in 2 dice. What is the probability of rolling a sum, say, greater than 4? We're looking at the probability of rolling a sum greater than 4. What that means, we're looking at rolling simply what? If we're looking at a sum greater than 4, we can have a 5, right? 6, 7, 8, 9, 10, 11, or 12. And that's the most you can roll, because 6 and 6 is 12, right? So there is a lot of ways to go ahead and roll a number greater than 4. If I were to sit down and write down all the combinations that could happen, that's probably going to take me a little bit of time. So first of all, let's figure out how many possible outcomes I could have with a rolling 6 die, two die. Okay, let's take a look at it. First die, how many choices do I have? 6. Second die, how many choices do I have? 6. If I roll them together, how many choices do I have? 36. Why? Because, let's say, let me give you an example. Let's say the first die was a 1. Yeah? With the first die being 1, the second die could be 1, could also be 2, could also be 3, could also be 4, 5, or 6. Correct? Yeah? Those are different outcomes, aren't they? So with the first choice, with the first die being 1, the other die can be one of 6 choices. Yes? Okay. So with 1, I'm getting 6. With 2, how many do I get? 6. With the 3, how many? 4 is also 6. 5 is also 6. 6 is also what? 6. So how many total outcome I'm getting? 1, 2, 3, 4, 5, 6 of the 6 times 6, which is 36. Again, we go back to their multiplication. if we do have two different outcomes, we have scenario or the event is happening simultaneously, right? You gotta have both events at the same time with the two dice, so you multiply their outcomes. Yeah. So now n of the sample space equals 36. Now we need to figure out how many outcome of those 36 is gonna be greater than what? Than 4. or or we could look at the complement of greater than 4. What is the complement of greater than 4? What is the complement of that? Hmm? Less than or equal to 4, right? So if I look at the complement of that, that'll be less than or equal to 4. How many options do I have in that one? 3 options. 2, 3, and what? 4. Which is easier to locate? This or that? This one is easier to know, right? So let's look at if this is event E, let's call E prime less than or equal to 4. Yeah? So let's see. In E prime, we have the dice can add up to 2, right? How can they add up to 2? What are the numbers shown on the die? 1 and 1, right? Correct? So they can add up to 3. How do I add them up to 3? Okay, well, we have to distinguish. We can say the first die is 1, the second die is 2, right? Or we could say the first die is 2, and the second is 1. Yes? Because those are two different outcomes. Especially we're talking about distinguishable die. Yes? So what are the options of rolling a 4? Well, we could say, let's see how can I add up to 4. With a 1, I can add a 3 to it, right? With a 2, I can add another 2 to it, right? With a 3, I can add a 1 to it, right? Can I go any further? That's it. All right. So how many options do I have for this one? We have 6 outcomes, so we can say probability of E prime equals 6 over 36, yeah? Which is 1 over 6. So what's the probability of E? We just said it's going to be 1 minus probability of E prime, and that is, what was that? 1 minus 1 over 6 equals 5 over 6. So now instead of counting everything, we already ended up counting how many? 6 options, right? And then we got the result. So sometimes it's nice or it's easier to think of the complement, figure out what the complement is, and subtract it from 1 to get the option, the event that you're looking for. Okay? Well, since we explained this, just for the heck of it, let's go ahead and continue with those. Let's see if they used it the other way. Would that be fun? So now continue with 4. What's the next after 4? 5, right? So how many ways I can get 5? Start with the easy ones, right? Start with 1 and go up. 1 and 4. And then 2 and 3, 3 and 2, anymore? Can't have 5 and 0. 1 and 4 is already there. That's why I start from the lowest and I go up, right? These are all my options. Okay, 6. 1 and 5, 2, 4, 3, 3, 4, 2, 5, 1. That's nice. So how many? Let's see, start from here. 1, 2, 3, 4, and that was how many? 5, right? So let's roll a 7. If they sum up to 7, what do I get? 1, 6, right? 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. How many? 6? Okay, let's go to one more. Let's go to 8. What do you think 8 is going to be? Nice choice. Nice guess. But it's not. That's the most you could ever have. 6 different choices, 6 different outcomes. Now, after you get to 6, what happens? Start going down. So with the 8, can I start with a 1? Can't have 1 and 7 because there is no 7 on the die, right? So it'll be what? 2, 6, and then 3, 5, and then 4, 4, 5, 3, and then 6, 2. Right? So now what happened? We went down from 6 to 5. So what do you think 9 is? 4, 10, 11, and 12. So you see how it goes? So really, if you know the pattern of those, you're going to see a whole lot of numbers or questions in the text that talks about rolling 2 die and then summing up to whatever number, right? So those do have a pattern. Yes? So 7 is the highest, which is simply 6. And then you can go, if you go up 6, below 6, you go down 1, and so on and so on. So the higher one you go, the lower one the number is. So 6 and 8 will be 1 less. 5 and 7 will be 2. 5 and 9 will be 2 less, and so on and so on. Yeah? So keep that in mind. Any question on the complement? Let's do one more on the complement and move on. Last time we talked about a couple having 3 kids, right? Okay, let's say for the couple having 3 kids, what's the probability at least 1 girl? So we want at least 1 girl in those combination of kids, yes? So let's see if we can solve this problem without writing anything. First, we need to figure out what the sample space is, yes? We need to figure out what the sample space is. What is the sample space? Last time we talked about this, right? We got a number. Let's see if we can figure out that number today over here. Getting the first kid. For the first kid, how many choices do they have? 2. It could either be a boy or a girl. So 2. So the first kid, we have 2 options, yes? The second kid, how many options do you have? Again, 2. Because it's going to be a boy or a girl, right? And the third one could also be what? Two with a boy and a girl. So how many total options now we have? Those events are happening simultaneously, right? So what is 2 times 2 times 2? 8. So my sample space is 8. So the n of the sample space is equal to 8. Now thinking about at least one girl, you could have one girl, right? You could have two girls, you could have three girls, all of these at least one girl, right? That's a lot to think about. What is the opposite of at least one girl? If you don't have at least one girl, what do you have? Boys. So the opposite of at least one girl is all boys, right? How many ways you can have all boys? Which one? All boys. All three boys. And how many ways you can have all three boys? Let me see. First one is a boy, second one is a boy, this is one way. Right? All three of them are boys, right? Because if there is any difference, that's not all boys. Right? So there is only one situation. So if E at least one girl, then E prime is all boys. And the only way you can get all boys is by having a boy, boy, and boy, right? That's the only option, right? So then, what is the probability of E prime? 1 out of 8, correct? So what's the probability of E then? 1 minus 1 8, 7 8. Yes? So this is also a scenario where it was easier to figure out the complement of the event we're looking for. Yeah? Because if you want to sit down and write all of these, this is only 8, but if you want to sit down and write them, you're going to find that the only way that you can't have at least one girl is by having all of them boys, and there is only one way that could happen, where all three of them boy, boy, boy. Clear? So the other 7 will have at least one girl. We can write them down and check. So we can have a boy, 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 right? You could also have a boy, boy, and a girl, yes? And you can also have boy, girl, boy, boy, girl, girl, or you can have a, a girl, boy, boy, or a girl, girl, and a boy, right? 2, 3, 4, 5, 6. Let's see what else we can have. You were already confused in that. So we can have a girl, boy, girl. Yes? What else can we have? One more. We can have all girls. Yes? So how many options do I have? At least one girl. This is at least one girl, right? This one, that one, that one, that one, that one. You see? And how many are these? 1, 2, 3, 4, 5, 6, 7. 7 out of 8, which is that. Which one was easier to look for? It was easier to know. If not all, at least one girl, there's all boys, right? And therefore, that was easy to deal with. Yeah? Any questions? No questions? All right. Two events are exclusive. That means probability A enter or union B, probability of A as probability of B. When we're looking at two events that are exclusive, what does it mean to say exclusive? Exclusive events are two events where they have no outcome in common. Yes? For instance, when I say we will roll a die, an event A, let's say the odd numbers, event B would be the even numbers, right? So those events have nothing in common. We call them exclusive events. Okay? So now let's go back to rolling a die. Okay, let A roll in a sum of 7. Let A be the event of rolling sum of 7. Let B roll in a double. A double means both numbers are the same in this case. Yes? Rolling a double means in this case both numbers that been rolled are the same. Yeah? So what is the probability of rolling a 7 or a double? So we're looking at the probability of rolling a 7 or a double. So of course we have two dice, all right? We're looking at two dice in here, right? So in order to figure out the probability of rolling a 7 or a double, we're looking at probability of A union B in this case. We're looking at A union B in this case. Yeah? All right. So to figure out the union, I need to figure out the probability of each one first. Okay? What's the probability of rolling a 7? So will be n of A divided by n of the sample space, correct? How many possible outcomes I get rolling a 7? We just did that just a second ago. Remember when I was putting all these numbers? Anybody wrote down what are the possible outcomes of rolling a 7? 6 of them. Divided by how many possible outcomes do I have in the sample space? In the sample space, all the outcomes from rolling two dice. What are the possible outcomes? How many? 36, right? So that is 1 over 6. Yes? All right. Now, what's the probability of rolling a double? How many ways you can roll a double on a two-sided, on a two dice? 6 ways, because you can run 1, 1, right? 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6, correct? So that will be 6. Again, how many possible outcomes do I have from rolling 2 dice? 36. And that is equal to 1 over 6. Yeah? So now I can say probability of A union B equal probability of A plus probability of B. I'll be 1 over 6 plus 1 over 6, 2 over 6. 1/3. Okay? So far so good? Any questions? All right, let's take one more. What's the probability that C equal rolling an 8? Rolling an 8. What's the probability of C? With 5 over 36. Yes? Okay, now let's do one more. Probability of C union B. What is B? All right. So what's the probability of C union B? Hmm? I didn't hear that. Well, if we follow the formula again, it should be probability of A plus the probability of B. In this case, will be probability of C plus probability of B, right? So, what's wrong with this formula? Well, there is one thing wrong with that formula, and that formula is wrong because rolling an 8 and rolling a double are not two exclusive events. What do I mean by not two exclusive events? There is one outcome in both of them, at least. Yes? Because when I roll an 8, I could roll 4 and 4, right? That is an 8. But that's also what? That's also a double. So if I say it is probability of C, I'm counting the 4, 4, plus the probability of B, I'm also counting the 4, 4. Yes? So that's going to be extra. So I need to subtract that. Oops. I need to subtract the common outcome between the two. Yeah? So now I can say this is true if they're not exclusive event. Yes? If those two events are not exclusive, then yes, I have to use that. Notice, if they are exclusive, then this is 0. So you end up with that. Yeah. So now what can I say? Well, probability of C is, what did we write it? Over here, 5 over 36 plus. We said probability of B is 1 over 6 minus, we only have one outcome in common. Yes? So the probability of this is 1 over 36. If we add all of these together, we end up with 10 over 36, 5 over 18. So when you're looking at a union of any event, you have to make sure to check whether those events are really exclusive, where they don't have anything in common, or do they have something in common? If they do have something in common, you have to subtract the probability of that. Yeah? All right. One more thing, which is you always hear the word odds. What's the odds of this happening? Yes? The odds of something happen is equal the how many outcome do I have in the event divided by how many outcomes I have in the complement of that event. Yeah? How many I have in the event divided by how many I have in the complement of that event. For example, rolling a die, the odds of rolling a 5 is not the same as the probability of rolling a 5. Yeah? The odds of rolling a 5 would be, well, how many 5s are there on the die? 1. How many number on the die that are not 5s? Well, total there is 6, right? 5. So the odds of rolling a 5 would be 1 to 5. Yes? So what is the odds of rolling a number less than 3? So what's the odds of rolling a number less than 3? First, we figure out how many numbers are there less than 3, yeah? And how many numbers are there less than 3? 2, right? How many numbers are there are not less than 3? 4. So the odds of rolling a number less than 3 is 1/2. Yeah? So now we could also adjust this formula by dividing top and bottom by the same number, correct? If we divide top and bottom by the same number, then we will end up with the same fraction, correct? So let's say this is equal the same as the number of element in E divided by the NS over NE prime divided by NS. So I divided both top and bottom by NS, right? But this is a formula for the probability. And this is the formula for probability of E prime. Okay? Any question on that? All right, let's take an example on that. The probability of rain is 1/3. So we know the probability of rain is 1/3. What is the odds of rain? So we have a 1/3 probability is going to be raining tomorrow or whatever. Yes? What's the odds that it really can rain? Well, to figure out the odds, we need the probability of the event divided by the probability of its complements. Yes? So if the probability is going to rain, what's the probability not rain? So probability of no rain, P E prime, right? Which is equal 1 minus 1/3. Is in probability of the event the complement. What's the complement of rain? Not rain, right? So the probability of the complement is 1 minus the probability of the event. Probability of the event 1/3. The complement would be 2/3. Yes? So now what's the odds of rain? Equal. Follow the formula with the probability. 1/3, 2/3, 1 to 2. So the odds are 1 to 2. Yes? This is basically what you learn from ratios in fraction. Or when you hear a commercial, the odds of this happening is 4 to 5 or what have you. Yes? So we can tell if they're, now notice, if I'm given the odds, how do I find the probability? Here's what the probability. That's the event. How many in the event, right? Given the odds, probability is 1, which is that, yes, divided by 2 plus 1, by dividing by those two. You add them. 1/3. Okay. We'll talk about this a little bit more later, next time. Any questions? No? Okay, that's it for today. You guys have a nice day. I'll see you back here on Wednesday. And Friday, we'll make a decision whether to show up or not.